In this video, we are going to discuss 3D scanning aircraft, specifically airplanes and helicopters. And what we're going to go through is some different subjects, including why someone would want to 3D scan an aircraft. We'll talk about the different applications that it would be used in. We'll talk about the different aircraft types and sizes. We'll talk about the actual process of how it's done, and we'll look at some of the typical equipment used for 3D scanning of airplanes and helicopters. We'll look at the deliverable. What is the end result, the end deliverable to the customer? And we'll go over some ideas of cost ranges, depending on different variables. And then finally, how to select a provider to do some 3D scanning, maybe modeling or inspection from that scan data. So let's start by talking about why would somebody want to 3D scan an aircraft. And there's a few common reasons that this is done. One of the most common is there is no CAD, no 3D data available. And that's usually because of the age of the aircraft. When it was designed and manufactured, they just didn't use CAD back then. They either didn't have it or just didn't use it. Or another common one is you don't have access to the CAD. So there may be CAD available, but you just do not have access to it. A third reason would be there is CAD data available, but it's not correct. So what happens many times through the years is planes get updated, retrofitted, changed, and it's not updated in the CAD. So even though there is CAD, it could be out of date, or the aircraft has a different interior in it, many different reasons. So the CAD data isn't correct. Another reason is, depending on what you're doing, the CAD may be too complex. Most current aircraft are completely designed in 3D CAD. But those files are huge because they're huge assemblies with thousands and thousands of parts. And maybe you just need the exterior or maybe just parts of the cockpit. Trying to simplify the CAD down to something that's usable just may not be possible, or just too difficult to do. And the other reason people scan aircraft is they want to do inspection. So most of these I'd mentioned already are usually for reverse engineering, where you want to build CAD. But nowadays, with the accuracy of these 3D scanners and the resolution, people are actually using them to do inspection. So they would scan either the whole aircraft or parts of the aircraft. Then they would import CAD data and actually do inspection and measure and see the difference of the as-built versus the nominal, which was the CAD. So those are some of the main reasons people want to 3D scan aircraft. Now, what are some of the applications that they want to use this scan data for? And here are a few of the most common ones that we see out there. One of the most common ones is they want to build a physical trainer or simulator. So a flight simulator, a maintenance simulator, something like that. They're going to physically build it. Or they might be building a virtual trainer, a simulator, so more of a software-based system might be the first step before they get into the actual physical trainer. So being able to use a virtual trainer. They might be updating or retrofitting the aircraft. So many times aircraft are put into service, especially military aircraft, for a specific task. And then later on in that aircraft's life, they may reconfigure it, take things out, add things on, put new engines that may require different supports, and just different things. So it's some kind of upgrade. Another thing is they might be doing some kind of analysis to the aircraft. This is software analysis, such as CFD, FEA, structural, things like that. And that could be in conjunction with retrofitting an aircraft. So for example, they might be adding stuff to the outside of the aircraft, different sensors, cameras, military weapons, things like that. And then they want to run some analysis to see how that's going to affect the flight of the aircraft or the structural integrity of the aircraft. So we will go and scan that aircraft with those things added on. They might be just analyzing an existing aircraft. They basically want to digitally document it, to go in and study it or do different things with it. And then, as I mentioned, inspection. Inspection is becoming used a lot. So to either 3D scan individual items or the whole aircraft and do inspection, basically, digital measurements to see if things have been manufactured correctly. Now, what are some of the aircraft types we see out there? Well, obviously airplanes of all shapes and all sizes, from small private airplanes all the way up to huge, your C-5s, your C-130s, your C-17s, very large military transport aircraft, helicopters, wide variety of size and shapes of helicopters, unmanned aircraft as well. And again, they can be very small, they can be very large, and all points in between. Sometimes just the exterior needs to be scanned, sometimes the interior, sometimes both, or just individual parts that they want to have scanned on the aircraft. Now, how is an aircraft actually 3D scanned? What does that process look like? Well, the first thing you need to do is look at many different factors that come into play when you're looking at having something 3D scanned. First one really is size. The bigger the aircraft, the more complicated it gets, the more equipment, the more people, the more ancillary equipment might be required to do any 3D scanning. In addition, location becomes important. How far away is it? Geographically, is the aircraft stored inside a hangar that's climate controlled, or is it outside, on a tarmac where it could be snowing or raining, and just temperature changes through the day could affect accuracy. It can affect equipment, so that's important. And then what areas are going to be scanned? Is it just the interior? Are you doing just the cockpit? The cargo area? Is the plane stripped out? Meaning, all the frames and stringers are exposed and the floors removed. Are you doing all the structural stuff, or is it a completely finished cabin with seats in it? Things like that. And then are you doing some individual parts as well? And then what level of detail and accuracy? And this is the really important one. Are they looking for what we call a high fidelity model that has, every button and switch and dial and cable? Or is it just a model that represents all the structural items in the airplane? For example, if you were going to build a physical trainer, you may just need all the structural stuff so that can be fabricated. And accuracy. Accuracy gets difficult to hold over distance. So if you're doing a very large aircraft and you're trying to hold a fairly tight tolerance, that's going to be more equipment, or maybe different equipment and different processes to be able to do that and do it accurately. So doing a very high detail scan and a very accurate model can be twice the time to scan, and could be more expensive, maybe require more people, etc. So those are some of the factors that are typically looked at when you want to look at 3D scanning any type of aircraft. Now, what about equipment? What type of equipment is used when you do any kind of 3D scanning of aircraft? And the answer is usually, well, it depends. Thinking back to that last slide, how big is the aircraft? Is it a high detail scan? Are we going in and getting into a very tight cockpit, or a cargo area, or up into a landing gear housing or something like that? So there's a lot of different equipment that can be used. The typical equipment is what's called a laser tracker, a long-range scanner, some handheld scanning equipment, Sometimes photogrammetry equipment is used, and you're going to typically use some very high-end laptops and or desktop computers. If you're doing a large aircraft at high detail, it's not uncommon for us to get 100 gigs or more of data and process that into a point cloud file that's 300 to 400 million points. So these are very, very large files, and also specialized software. This is not done with CAD software, typical CAD software that you see out on the market. It's very specific software for scanning, reverse engineering, and inspection. So you really have to have that. And on top of all of that, it's really the knowledge to use all this different kind of equipment in the right way to do the job properly.